Welcome everybody to this new episode of CCIR Student Spotlight. With me today is Laasya Chandrapaty. Laasya is currently a rising senior in the Basis Independent School in Fremont. While at CCIR, Laasya joined Dr. Biral I of Harvard's course on regenerative medicine. And while at her time here, Laasya worked on a project specifically focused on diabetes. So today we're really inviting Laasya here to talk a little bit about her experience, about her research and her time at CCIR. But just to begin, I want to say, Laasya, thank you so much for coming on the Student Spotlight series.
Yeah, thank you so much for having me.
So let's begin very briefly, Laasya, with an opening question, which is, how did you initially come to CCIR? And in particular, how did you initially decide on working in this broad area of regenerative medicine?
So I first came to CCIR by doing my own research online because I wanted to get into researching as a high school student. And so I was searching online for different programs that I could use to, enhance my learning experience with what would be researching for the first time as a high school student. And generally, I am really interested in regenerative medicine, especially because tissue engineering is a type of regenerative medicine, and the overlap between biology and engineering is a topic of interest to me. And so that's how I chose going into this specific course with Dr. Biral.
So for those of us who are who don't know, could you, in sort of brief layman's terms, explain to us what regenerative medicine is about?
So regenerative medicine is generally about how the body heals itself and how we as humans can provide different ways for the body to heal itself better. So tissue engineering, it can also include wound healing, like skin transplants, as well as basically helping the body regenerate itself. So it's not creating something out of nothing.
And tell me a little bit more about specifically this aspect of tissue engineering. So what exactly is tissue engineering within the context of regenerative medicine?
So tissue engineering really helps with regenerative medicine in that, especially with type 1 diabetes and the pancreas. In type 1 diabetes, pancreatic cells are destroyed by our body's own immune system. And to regenerate those cells, the body has a really hard time doing that when it's being constantly attacked. So tissue engineering would help in type 1 diabetes, especially by providing a sort of protective layer around the cells and allowing them to grow back generally.
Cool. So as I understood, your main research project focused in particular on the applications of regenerative medicine in diabetes. But before we get to that, I want to quickly ask you sort of your journey to actually find your research topic. Because one of the most difficult things in research, as surely you know, is actually finding a topic that would be at once something that's interesting to you, as well as feasible, and so on and so forth. So I want to ask a little bit about sort of how you eventually resolved on looking into diabetes.
So generally, in the beginning, I wanted to do neuronal cell research on like the brain and how we can regenerate the brain. But I realized that after seeing a post on the first pancreatic cancer mRNA vaccine, I think it was pretty recent actually, and it was really interesting. But after I saw that, I realized that I could do a lot more in the field of pancreatic tissue engineering and help a lot more people that way, since research is advancing in that field a lot faster than in neuronal cell research. And I was also generally more interested in pancreatic tissue engineering because I have a history of diabetes in my family. And so that was also really interesting to me because I feel like I could improve the quality of life of people who are affected by type 1 diabetes.
Can you tell me a little bit more, because as someone who doesn't know this stuff, tell me a little bit more about this groundbreaking discovery of the, or this development, let's say, of the pancreatic mRNA vaccine.
So these vaccines, they've been working on them for a really long time. It's kind of like the CAR T cell therapy for cancer, in which they genetically modify the T cells in your own immune system to target cancer. And I was looking at ways to take that cancer vaccine and put it towards maybe suppressing the immune response that the body has towards the insulin producing cells in the pancreas in type 1 diabetes. So in type 1 diabetes, the immune system attacks the cells in the pancreas. And so I was looking for a way to change the way those T cells were looking for the bioactive markers on the pancreatic cells, and the way so that they don't have the memory to attack those cells, if that made sense.
That makes, I mean, as much sense as my untrained brain can make of it. But that's really interesting. It's also interesting to hear that your scientific project ultimately reflected certain parts of your own personal history and personal experiences. So I want to pivot a little bit here and ask you a little bit about what it was like, in particular, working with Dr. Birolai, who is a faculty member at the Harvard Medical School, and working with TAs who are similar in this sort of caliber within the context of the Future Scholar course. So what was it like working with Birol, and in particular, working at this sort of level of complexity and intensity?
So this was really the first time I had such an intense course in research, and it was really interesting, and it was a learning experience. And with Dr. Birol, he made the course extremely fun and interactive, and he would pivot topics sometimes. He had a lesson plan, but if we were interested as a group in something else, he would pivot to that topic, and that ultimately made the learning experience much more enjoyable. And the TA, she helped so much, and it was really nice, especially to have her help throughout the process of writing a paper, and also reading the papers to help write our own papers, because it had been my first time really diving into academic papers and academic writing. And she really helped with the understanding and to foster learning with us as well in reading the academic papers. So that was really nice.
So tell me a little bit more about your experience of the differences between, let's say, writing a scientific paper and writing a more conventional high school essay.
So for a high school essay, generally, I think those essays, you don't really need to do as in-depth research, as well as you don't need to do as much specific citing of your evidence to avoid plagiarism. You can simply put a bibliography at the end, and that would be done. And sometimes most high school papers, they don't even require you to cite your sources. And so that was one thing I kind of struggled with at the beginning, because I left my sources at the end. And so I had to go back through my paper and reread like 15 different papers to try to figure out where I got specific pieces of information from. And that's one of the main differences. Another difference is that in academic writing, like writing research papers and such, you have to read a lot more than generally in a high school paper. You have to do a lot more research. You have to read like 50, 100 papers to put out one paper yourself.
That's true. And when it comes to reading papers, because some people, as someone who's like done research before, I'm sure you know, there's actually tips and tricks to reading papers well and reading them efficiently. Have you found that in your process of working with research papers, you've gotten better at working through them and understanding how they work?
I would say I definitely do have the increased capabilities to understand academic papers, but I'm still learning, and I hope to eventually understand more than I do right now. But it has been a really great learning experience, and I do feel like I have understood more with the tips that the TA gave me to read the paper, such as breaking it down into smaller parts. And if a paper is too hard for you to read, or you feel like you don't understand all of it, just try to understand the parts that you think you can, and go into the bibliography section, and you'll be able to click on different papers that the paper you're reading has referenced. And usually those papers will be easier for you to read, the papers that this paper has referenced.
Mhm, mhm. Yeah, that's a really good tip. Follow the paper trail and the references. I think one of the other aspects that I want to ask you a little bit right now is what it was like working with other students as well, because one of the unique things about CCIR is that it brings together kids who, 16, 17-year-old kids who all happen to be, let's say, interested in regenerative medicine or in, let's say, computational astrophysics. So that's usually a pretty odd setup. And tell me a little bit about your experience working with your peers.
So my experience working with my peers was really a great experience, to be honest, because it was like we were doing our own separate projects, but we were still cohesive as a group, and we were still helping each other with our own projects. Because I remember we had specific sessions where we would go over different types of tissue engineering, and everybody would have to bring one paper to the table to help the person doing that type of tissue engineering. Like we had one day about heart tissue engineering, and I had to bring a paper about heart tissue engineering to their Zoom meeting and present it, so to help the person who was doing their research project on heart tissue engineering. And so that was really interesting, and it also expanded my knowledge in the field as well, because we did heart tissue engineering, cartilage engineering, we did skin tissue engineering, and also pancreatic tissue engineering. So it was kind of a broad range of ideas that really helped foster understanding of the field in general.
Cool. That's really great. I didn't know that Viral did this particular structure of getting a student to bring in a paper for another student. That's a really cool idea. So I want to also ask you a little bit now about how this process of doing this sort of super intensive course, as you mentioned, and doing research and doing sort of on the ground scientific work has changed your perspective on, let's say, either academia or on science in general.
Well, I think when I was younger, like when I was a little kid, I thought research was mainly just, mixing chemicals together and occasionally having explosions. But as I went through this course, and as I grew older and looked more into scientific research, I think that I realized that it was a growth of knowledge rather than just having some fun mixing chemicals. And this course really taught me the importance of academia in general, because we had to go through so many papers, and they covered like such niche topics that you wouldn't even know were important until you found a paper that referenced another paper that you had read and saw how important that one specific discovery was to making more discoveries along the way.
That's really, really great to hear, because as part of, let's say, the mission of CCIR is really to give students a better understanding of what academia does and what research really is. So it's really great to hear that that you had this perspective. So as we're sort of coming towards the end of this interview, I want to bring up a question that I ask every student that I do this student spotlight with, and that is, as someone who's gone through the trials and tribulations of doing research and doing the CCIR course, You, of course, know that it's a really difficult and sometimes exhausting and sometimes even exasperating experience. But I want to ask you, like, what would you say to a student, let's say, who's never done research before and who is a little bit cautious about approaching research for the first time? What would you say to such a student who is, let's say, a little bit daunted by research at this stage in their career?
I would say don't be afraid of learning, especially since it's your first time doing things. You don't have to be perfect at it. And it's supposed to be a learning process if it's your first time doing things. I know I really struggle with that a lot because I'm a bit of a perfectionist when it comes to work. So if I don't get things right the first time, it's a little bit discouraging, but you have to get through it. You have to push through it and learn to be better at it, is one of the pieces of advice I would give. And also, it can be overwhelming to write a research paper and read all of these papers. And if you feel yourself getting so frustrated that you can't write everything and it's a break, just take a break from your computer. Like, just step away and do something different. Don't even think about research and come back to it. And that will really help, because I know that really helped me a lot when I was getting really frustrated with writing my paper.
That's a great piece of advice. Just take a break. I really feel that as someone who's also been through the hell of writing writer's block. So with that, Laasya, that really begins wrapping up our podcast. I want to say that thank you so much for taking your time to join us today. It's been a wonderful conversation, and it was really great to learn a little bit about your experience, about the work that you did, and to hear a little bit about your perspective on research and academia. So with that, I just want to say, Laasya, best of luck in all of your future intellectual and non-intellectual endeavors. And thank you so much for joining us today.
Thank you so much for having me.